Imagine a world where AI agents not only answer questions, but also reason, plan, and act with autonomy. This is no longer science fiction. Thanks to advances in large language models, AI agents are now capable of handling complex tasks that once required human intuition. In this video, we'll explore how AI agents can scrape the web, analyze sentiment, and generate interactive dashboards, all with minimal human intervention. We'll walk through a real-world project that leverages Crawl4 AI, LangGraph, LangChain, and Streamlit to create a self-sustaining sentiment analysis dashboard. Let's dive into how this technology is reshaping data science workflows. AI agents are quickly becoming one of the most practical applications of large language models. Unlike traditional systems that follow strict logic, AI agents can adapt, reason, and use various tools to achieve their goals. This flexibility is transforming how we approach data scraping, transformation, and visualization. Instead of spending countless hours maintaining brittle pipelines, teams can now rely on agents that adapt to changes and keep dashboards up to date. The result? Faster insights, lower costs, and more time spent on innovation rather than maintenance. In this project, we build a sentiment analysis dashboard powered entirely by AI agents. The system scrapes headlines from major news outlets like CNN and Fox, analyzes the emotional tone of each headline, and presents the results in a dynamic dashboard. Visualizations include Sankey diagrams to show sentiment flow, bar charts for outlet comparison, and word clouds highlighting trending topics. The entire pipeline is automated, from data collection to dashboard refinement, demonstrating the true potential of AI-driven workflows. Building a data product is only half the battle. The real challenge lies in keeping it running. Technical debt, or the ongoing cost of maintenance, can consume up to a quarter of a team's time. Web scrapers are especially fragile, often breaking when a website changes its layout. Dashboards, too, require constant updates to remain functional and visually appealing. By automating these processes with AI agents, organizations can reduce maintenance cycles, save on operational costs, and focus on delivering value. Imagine a system that not only scrapes data, but also adapts to changes in website structure and regenerates dashboards automatically. That's the promise of AI agent-powered pipelines. These systems can decide what to scrape, process the data, and update visualizations, all without manual intervention. For businesses, this means fewer disruptions, faster insights, and a more agile approach to data-driven decision-making. At its core, an AI agent is a system that perceives its environment, makes decisions, and acts towards a goal with autonomy. This broad definition covers everything from trading bots to smart thermostats. In the context of this project, AI agents are powered by large language models, enabling them to reason, plan, and execute tasks using external tools. The ReACT framework, short for Reason and Act, guides the agent through cycles of reasoning, action, and observation until the goal is achieved. The ReACT framework is a popular approach for structuring AI agents. It starts with a system instruction that defines the agent's goal. The agent then reasons about what to do, acts by calling a tool or API, observes the result, and repeats the cycle. This loop continues until the agent achieves its objective. By combining reasoning and action, ReACT agents can handle complex workflows that require both decision-making and execution. Instead of relying on a single, all-purpose agent, this project uses a team of specialized agents. Each agent focuses on a specific task: data collection, visualization, or refinement. This multi-agent setup offers several advantages. It improves accuracy, since each agent is an expert in its domain. It also makes debugging easier, as errors can be traced to a specific agent. And its more scalable agents can be added or replaced without disrupting the entire pipeline. The project's architecture features three main agents: the data agent, the visualization agent, and the refinement agent. The data agent scrapes and organizes news headlines. The visualization agent creates charts and assembles the initial dashboard. The refinement agent tests, repairs, and iterates on the dashboard until it's polished and error-free. Together, they form a robust pipeline that delivers reliable, up-to-date insights. Crawl4 AI is a next-generation web scraper designed for the AI era. Unlike traditional scrapers that break with every minor website update, Crawl4 AI outputs clean, structured data that's ready for AI pipelines. It's resilient to layout changes and efficient in its use of tokens, making it both fast and cost-effective. This tool forms the backbone of the data collection process in our Sentiment Dashboard project. LangGraph and LangChain are the frameworks that bring our agents to life. LangGraph provides the structure for building React agents, handling reasoning loops, tool orchestration, and error handling. LangChain acts as the glue, initializing language models, wrapping Python functions as tools, and managing agent communication. Together, they enable seamless integration between AI reasoning and real-world actions. Streamlit is the library that turns raw data into interactive dashboards. It's widely adopted in the Python community for its simplicity and speed. In this project, Streamlit is used to generate the entire dashboard automatically, making it easy to visualize sentiment trends, compare news outlets, and explore word clouds. The result is a polished, user-friendly interface that updates itself as new data comes in. The workflow begins with the data agent, which scrapes headlines and runs sentiment analysis. Next, the visualization agent creates Sankey diagrams, word clouds, and comparison charts. Finally, the refinement agent tests and improves the dashboard code, ensuring everything runs smoothly. This pipeline is orchestrated to run automatically every day, keeping the dashboard fresh and relevant without manual intervention. While working with autonomous agents is exciting, it comes with its own set of challenges. Balancing autonomy with control is crucial. Too much freedom can lead to unpredictable results, while too many guardrails can stifle flexibility. Debugging agent workflows requires careful inspection of both reasoning steps and tool calls. Output randomness can be fun for experimentation, but may not suit production needs. Persisting outputs and refining features over time can help strike the right balance. Currently, the project runs locally, but deploying it to the cloud would make it more robust and accessible. Containerizing the app with Docker and using platforms like Streamlit Community Cloud or Google Cloud Run are potential solutions. As AI agents continue to evolve, we can expect even more powerful, autonomous systems that handle data collection, analysis, and visualization with minimal oversight. The future of data science is here, and it's agent-powered.